Grinding is a crucial step in the mining process. This is the reason why the Siemens Gearless mill drive, or GMD, is the essential piece of equipment for a concentrator plant. It is outstanding in terms of availability, reduced costs, and high performance to cope with the production requirements of a mining operation. In Chile, in Anglo-American's Los Bronces mine, the GMD solution has been implemented for the Confluencia concentrator plant.
We have expected the ramp-up to take approximately 12 months. But actually, we've already achieved the respective levels of production, reaching almost nominal production around the 4th or 5th month. In this plant, we have as our main equipment a SAG mill, 2 ball mills, and 2 cyclone pumps, serving as standby to each other. These are engaged to transport the pulp through the mineral production process. The variable speed of the mills is an important advantage, which we use in many circumstances. It allows us to carry out a finer operation. It allows us to better control the process. It allows us to avoid damaging equipment due to excessive speed. Having variable speed for the mills has led to a remarkable change in the operation of the mills.
This is the Los Bronces concentrator plant. In contrast to the Confluencia concentrator plant, which uses the Siemens GMDs, this plant is based on the traditional dual pinion drives configuration with girth gear and synchronous motors with air clutch.
In order to achieve the same results with pinion drives, you would definitely require increased mechanical and hydraulic maintenance. More space is needed to perform the task. I would say it would also require more man-hours for the maintenance. In the case of the pinion drives, the pinions regularly need to be realigned with the girth gear. Regardless of the maintenance that they undergo, the pinions and girth gear need to be replaced after a certain time.
On the other hand, the gearless drives of the Confluencia plant are an innovative solution to reduce the mill's maintenance time. The frozen charge shaker, developed by Siemens, allows for frozen or cemented charges to be released in a quick, safe and controlled manner, hence avoiding manual loosening activities.
In July 2012, when the plant underwent a scheduled 100-hour shutdown, we needed to use the frozen charge shaker in order to turn the mill and continue with the change of liners. The main hazard of having a frozen charge is obviously damage to the mill itself, to the so-called shell that the liners are bolted to. If we try to turn the mill during the maintenance work, the frozen charge can be lifted and then fall sharply onto the shell, which can literally cause the shell to break into 2 or more pieces. This has happened at mines in the north of Chile and represents an absolutely catastrophic failure. Consequently, you have to change the mill shell, and it involves an extension of the maintenance period. The work has to be scheduled and specialists have to be brought in. Therefore, this causes a significant loss in the yearly production of the plant. Actually, the savings, compared to such a catastrophic failure, are practically 100%. If we would face a frozen charge in one of our mills without having the frozen charge shaker, we would need to send workers into the mill to remove frozen charge manually. This could take around 10 to 20 days. By applying the frozen charge shaker, we are able to remove the frozen charge in a maximum of 20 to 30 minutes without any problems. In the Confluencia plant, we have achieved a significant increase in the plant's availability and operating time. We will end this 3rd year with an operating time of around 94% and a plant availability of around 95%. And that puts us right up at the top of the industrial sector worldwide. An important part of that achievement has been the excellent availability of the electrical system of the Siemens motors. In the 3 motors in the SAG mill, and the ball mills at the Confluencia plant. We have also invested a great amount of effort into the operator's awareness of the importance to eliminate spillages in the presence of dust and humidity in the system. Furthermore, there are the checks of all the ring motors we carry out periodically in parallel to the major maintenance work. That allows us to give these motors the necessary maintenance in order to ensure their long lifetime. In Plant 1, we have lost around 1% of operating time this year due to problems with the mechanical transmission system, which we didn't have in Plant 2, where the gearless motors are installed. The higher reliability of gearless technology and minimized need for maintenance interventions has allowed us to be well positioned in terms of the plant's availability and operating time. Considering that this equipment is the chosen technology for this kind of project, with millions of dollars involved, it's because this equipment is recognized as the most reliable in the market.
Achieve a higher productivity with the Siemens Gearless Mill Drive.